So our speaker is Tejas Chopra. He is a senior software engineer at Netflix, and he is going to share with us now his experience with DevOps, specifically at Netflix. So please welcome to the virtual stage, Tejas Chopra.
Hi, everyone. My name is Tejas Chopra, and it's an honor to be presenting from the United States of America to all the fellow folks in Armenia. It's too sad that I couldn't be there in person, but I would love to thank everyone in the country for inviting me and would love to visit Armenia in the future. With that, I would like to talk about how DevOps has evolved in a company like Netflix. Hopefully, you've all been aware of Netflix as a company and you know the software development practices that are there in Netflix. Netflix is not just a streaming company, it's also making movies. So through this presentation, I would love to educate people about how software development practices happen in Netflix. So the agenda for the talk is as follows. I'll talk about myself, what I do at Netflix. Then I'll talk about Netflix as a company. Finally, I'll get to the DevOps part, where I will just tease apart what DevOps really means, what DevOps means in the context of Netflix, in the context of Netflix culture, and I'll just keep some time for question and answers at the end. So I'm a senior software engineer at Netflix. I work on cloud infrastructure, specifically storage, for the Netflix movie side, movie making process. Movie making is very nuanced compared to streaming because only 1% of the data that is there in the movie actually makes it to the screen. So you can imagine it's a significant data and compute problem that you have to solve using cloud infrastructure. I work on architecting that. I'm also the founder at GoEB1, where I actually help immigrants become thought leaders in the US. I'm awarded the Tech 40 Under 40 by the National Diversity Council in US. I have worked at companies like Box, Samsung, Apple, and Cadence. I'm a TEDx speaker, and I have spoken on blockchain, cloud, and distributed systems. I'm also an adjunct professor. I teach students about software development in Arizona. That's the University of Advancing Technology. So Netflix, as a company, wants to win moments of truth. What does that mean? That means that every night when you come home or every weekend, you have an option to look for entertainment. Netflix wants to win those moments where you get delighted by watching Netflix. That's why we've started games. That's why we have now, started improving our catalog of entertainment. In order to win these moments of truth, our infrastructure has to be designed to be scalable and readily available across the globe. At a very high level, this is how our infrastructure looks like. We have compute and storage almost completely served out of AWS. We started having the streaming done using the CDNs, the content distribution network provided by Akamai. But we realized that because it's a core business value for us, we would rather have that owned. And that's why we came up with Netflix Open Connect. It's open source. It's our open source content distribution network that runs on all the internet service providers around the world. So at a very high level, this is what Netflix infrastructure looks like. And let me now talk about the scale when we talk about Netflix. Netflix serves more than 220 million members around the world. We operate in more than 190 countries in the world. We have thousands of microservices, thousands of daily production changes, tens of thousands of virtual machine instances. These include containers as well. Hundreds of thousands of customer interactions per second, millions, actually billions of time series metrics, tens of billions of hours streamed every quarter. And we do this with just tens of operations engineers. And we have no network operations center. A long time ago, Someone took a stab at explaining how different services in Netflix talk to each other. They came up with this graph. As you can imagine, there is no one in Netflix or outside of Netflix who understands what the hell is happening in this graph. It is extremely complicated to reason about any microservice here. That's the beauty of the infrastructure and architecture we have at Netflix. So now let me move on to a broader topic. Many people talk about DevOps. That DevOps is the new thing. You have to be a DevOps engineer more than just a software engineer. What exactly is DevOps? I'll try to tease this apart in the next few minutes. Software development has undergone changes. When you think about software, the process of developing software is you write a piece of code and it should run somewhere. And then it should enable and delight customers. There are various ways from writing the piece of code to it running at the customer on the customer's device. The process of doing that is what DevOps is, or what we've evolved to call DevOps. Initially, we started with the waterfall technique, then we moved to Agile, and nowadays we are in DevOps. So let me talk about waterfall first. As you can imagine, it looks like a waterfall, that's why it's called a waterfall. It's a traditional approach to software development. In this, what happens is, as a software team, you first gather all the requirements from your clients or customers. Then you spend time in different phases of development. You spend time in the design phase, in the development phase, testing, maintenance, release. Deployment happens or development happens in a step-by-step manner in the waterfall model. This seems very logical because you want to first collect all the requirements before you start building something. However, there are challenges, at least in the modern architecture. And the challenges are client requirements cannot be understood at once. Let's say a client comes up with a request for an application and you build it after spending 6 months. And that's when the client says, hey, you know what? I want to add this feature to this application. Or, hey, you know what? I think this application that you've delivered to me is great, but it is not giving me value. I need more things to be developed. So it is very expensive to make changes at the end of the project, because any change requires you to go right at the top of the waterfall and then cascade down to make the subsequent levels. And as we are evolving, as you can see, the world around us is developing software faster than ever. Software must be developed with lesser resources. That's been the requirement. And that is where waterfall model is not something that a lot of companies are adopting. Waterfall model works great when you're working on hardware, however, because with hardware, it's very rare to go back and change something once the hardware is built. So it's something that fits some particular types of industries and enterprises. However, if you are a typical web application provider or a software engineer that works on web apps, waterfall model is not something that you'll generally see. Then following the waterfall model came the agile model. The agile model is very commonly known in many companies. Here, the idea is that the entire process of building software is broken down into small actionable blocks. You can call it iterative development, where you iterate, you make something small, then you make something small again, and slowly things start coming together. Each such small unit is called a sprint. Which is very similar to when you're running. You sprint for shorter periods of time and you jog for a longer period of time. And a sprint is, as a unit, is very consistent in the sense that it has a planning phase, a coding phase, a test phase, and a review phase. You can think of, hey, you know what? You are wanting to build an aeroplane to go from place A to place B. But the agile way of doing it is to first build a bike and then build a car and then build an aeroplane. And that's the agile methodology that is much better than the waterfall one. So the workflow of a typical agile model is this. You have a backlog of requirements from product. You then do a planning of your sprint where you folks come together, discuss and decide which are the tasks from the product backlog that need to go into this particular sprint. In the sprint then, you plan, code, test, and review. And as the outcome of that sprint, you have a deliverable product, which is a deliverable feature, actually. and the product is delivered much faster as compared to waterfall model. However, even with this model, there are disadvantages because for every sprint, you're effectively building something on your laptop and testing it there, but you are not deploying it to production. That's the problem. The product only gets tested in production towards the end. And the other thing is, there are two types of engineers in companies. There are developers that develop software. There are operations folks that actually take that software, put it to cloud or deploy it, or deploy machines that run that software. They operate in silos in this particular model because it's the developers that keep delivering on the sprints. And once all the sprints are done, that's when the code is thrown to the operations folks to actually deploy it to cloud or somewhere else. And that's the problem that DevOps tries to solve. The word DevOps itself contains developers and operations. That's why it's called DevOps. And it's an evolution from the Agile model of software development. So as Agile solved the problem between the client's requirements and development and testing, DevOps tries to address the gap between development and testing and operations and infrastructure. According to DevOps practices, the workflow for DevOps in software development and delivery is divided into 8 phases. Let me just briefly explain. Many companies use only subsets of these 8 phases and do not actually use all the 8 phases. In the planning stage, which is the first stage, the business owners and the software development team discuss project goals and create a plan. This is followed by the coding phase, where programmers design and code the application and use tools like Git to store application code. The next phase is the build phase, where you have developed a code, but you want to build using tools like Maven and Gradle. Actually, Gradle is used very actively in Netflix. Finally comes the testing phase. We use JUnit and Selenium again to test a lot of our Netflix code. We use Jenkins for the integration. A lot of you would be aware of all of these tools that I'm broadly referring to. But if you're not, I would strongly advise, and I have a slide on this where I just broadly outline some tools you can use. When the testing is complete, the new features that you've developed have to run on top of the older code base. So this is where integration comes in handy. And then you deploy it. The deployment, again, what it does is it packages the application after release and it is deployed to production machines. Finally, once the software is deployed, operations teams performs activities such as configuring servers, provisioning them with the required resources. In Netflix, the deploy and the operations stage are together, chunked together. This is followed by monitoring. Monitoring is where you have alerts and you have some other specific metrics that you track for services that keep you that make you aware of how the service is being used. So this is a slide that tries to break down some of the tools that are used commonly by companies. In the planning phase, you have and the coding phase, you periodically commit code, so you use Git. We have our own internal thing we call Stash, which is built on top of Git. We use Gradle a lot for building. We use JUnit and other sorts of unit testing for our test phase. For integration, we use Jenkins. For deployment and operations, we actually use, we have Docker containers, but we've also built our internal Kubernetes equivalent called Titus. That is the container orchestration platform. Also, Netflix, and I'll come to this point in my slides in the next few slides, where we've built something called a Spinnaker. Spinnaker is our deployment platform that helps us deploy, configure servers, and scale them on cloud. For monitoring, we again have internal tools, but you could use Splunk and Nagios effectively. So given a background about DevOps, how does Netflix really do DevOps? Or what does DevOps even mean? Or does Netflix even have a team that does DevOps? The short answer is we don't do DevOps, actually. You might wonder, this entire presentation is about what DevOps is in Netflix, and I just said that we don't do DevOps. Well, we don't do DevOps in the traditional sense. We do not have systems that say no to our engineers. Everyone has full access to production environments. There are no push windows. We don't take time to build systems or have procedures and processes that prevent people from pushing their code. What we do instead focus on is freedom and responsibility. One of our goals at Netflix is to hire smart people and get out of their way. If I hire someone who is good at what they do and is intelligent, then they need to have the freedom to solve problems in the way that they see best. We also look for people that take responsibility and do not wait for it to be given to them. We do not optimize for uptime at all costs. There are many companies and organizations for which uptime at all costs is very important. These are companies in healthcare, in finance. I worked previously in companies like Apple and Box, which has very critical data. For them, they would actually prevent developers from pushing code because uptime was so critical during quarter ends. However, Netflix is different. We do not optimize for that. The repercussions for downtime in those companies are very different. What we do focus on is the velocity of innovation. At the very core, Netflix is a creative company. We want the smart engineers that we hire find new ways of delighting our customers. And Netflix as an organization realizes that we will have to trade some of the uptime for this. It is not that uptime is not important. It is just that it is not our priority. It is keeping our engineers doing fun and interesting and exciting things for our millions of customers. We do not believe in having processes and procedures. It is very difficult to have a fast-moving organization filled with people that solve interesting problems to have someone build guardrails that are appropriate. That is a very bureaucratic way of thinking. One of the functions of bureaucracies is to take that bureaucratic machine and plug in virtually any cog and get the output that the bureaucracy wants. That is not what we are doing at Netflix. Instead, we focus a lot on trust. We work hard to find people that are not from the bureaucratic machine mold. We want them to question how we do things. We want them to challenge us and suggest us newer ways of doing things. So we trust the people that we hire. That's why we do not have any issues giving everyone access to production environments. Someone can say, hey, you know what? Someone can bring production down. That has never happened though. We do not force people to use a language or a framework or IDE. At Netflix, when we develop software, we actually have a lot of languages. We have JVM, we have Scala, microservices are written in Spring Boot, Kotlin, Python. I worked on a file system that was written in C++, and some amount of Go as well. There's lots of Rust, Node.js, and other sorts of languages that are more newer in nature. That is to say, we do not tell people to write code only in a particular language. We give them freedom to choose the language that they believe is the best suited for the task. Now, that is the thing that I really like as an engineer, and I'm sure a lot of you can relate, where given a task, there are 10 different languages that you can write that code in, but you would want to pick the one that you're most comfortable with, or the one that has less boilerplate code that can directly come and solve problems, have automated tests that are integrated easily. So that's an advantage of not enforcing standards, which Netflix has tried to follow. What we do focus on is enablement. And what enablement means is there are some teams in Netflix that work to build common libraries that can be used by these languages. A very good example is logging or metrics. If you start thinking about DevOps, if you start thinking about software development, and if everyone starts using their own language of developing, then you will not have one particular issue can result in you looking at different metrics windows just because they are developed using different software. Now, what we want is the ability to still have a uniform, holistic view of the entire system. We want to know why a particular show did not show up in one country. And so what we did was we took a step back and we said, even though you can use different languages, let us try to build a common infrastructure that can be used to serve these different languages. So we have services with their clients written in different languages. And that is the essence of enablement. In our team, in my team, when I was writing the file system, I evaluated Java, for which some of these tools were written. However, I picked C++ because file systems would be faster if written in C++ than in Java. A lot of you who work with Fuse, which is file system and user space, would relate to that statement. And so, because there was no implementation of the metrics alerting framework in that language, I had to write that. And that is the expectation we have at Netflix. If you're doing something that's very new, that's very radical, you own it as an engineer. And for an engineer who is generally very curious, this is a great opportunity to actually expand their scope. So we focus a lot on enablement. We do not build silos or walls or fences. And we do not believe that operations is separate than development, which is why I said we don't do DevOps in the traditional sense, because all of our engineers in some ways are DevOps engineers. It's an engineer's responsibility to not just write code, but deploy it and monitor it and build all the necessary infrastructure that is needed to get that application successfully running. So we do focus on making ownership easy. Like I said, you build it, you run it is how we believe our engineers get the maximum freedom and responsibility. If I write code, it is my responsibility to choose the right machine in cloud that can run that code, which means I need to understand what are the different alternatives present when it comes to memory, CPU, or network, and then pick and choose the ones that would best satisfy the needs for my code and application. To help enable that, again, we again took a step back and looked at enablement, and we came up with Spinnaker. Spinnaker is our tool that allows people to deploy their apps to cloud or on-premise systems. You should go check it out. It's open source, and it's heavily used by companies around the world. So in some ways, we do not rely on guesses, gut instinct, and tradition. We instead focus a lot on data. Netflix is an enormous data company. Every quarter, we collect 2.5 billion time series metrics. A vast majority of our decisions is based on data. We started streaming in the year 2007. The first few things that we were streaming or movies that we were streaming were streamed from our data centers. In 2008, there was a fire in one of the data centers, and we had a decision to make. Should we continue to build data centers, or should we actually focus on what is giving us our value proposition, which is the movies that we are streaming, and build the streaming pipeline? We believed that the cloud infrastructure providers like AWS are much better than us at running data centers. So we would rather have them do it. And so we began moving to cloud. All of this was informed by data. Once we finished the movement to cloud in 2015, all of our services were running in AWS, and we focused on streaming. Come 2020, we realized that, you know what, compute is very expensive in cloud, as many of you may know, and our bills were running very high with AWS. So we realized that it would be actually best served if we could pull some aspects of compute back to data centers, run our own smaller data centers for doing some specific jobs like rendering of images. This is especially true when you're making a movie. And so the movie making process, again, gave us an opportunity to re-examine or take a look again at our decision and move some parts back to data centers. This shows how agile we are in actually taking back a decision as well. A lot of you know that Netflix did not have ads for the longest period of time. And today we have ads on our platform. So any organization that is flexible and agile in its thinking and bases its thinking on data is an ideal organization for DevOps. The other thing I would like to highlight is at Netflix, there are no televisions that show graphs of how services are doing. You know, that's very common in many big enterprises where you have like a wall full of screens that shows you these are the metrics, and there are people that are staring at it all day. We realized that the amount of metrics we collect, it would just be impossible to have one wall that covers all these screens and have the number of people to look at it. So we have automated most things where we get alerts only when services are observing some behavior that is not expected. And our microservice architecture allows us to build alerts specific to some services. That's the beauty of actually splitting it and not having a monolithic code base for Netflix. Um, we are a data-driven and a decision-driven company, so we invest a lot in data and algorithms. So in some ways, we do not really do DevOps, but we do focus on our culture. The first thing that we do when people come to Netflix or join Netflix is we ask them to read our culture deck. And I would strongly advise a lot of people to go and read that one, because DevOps at the end of the day is a result of a healthy culture and healthy thinking. And if whatever I said in this presentation, if nothing of this is something that your company is doing, then it may actually benefit you to go and look at some of these aspects of how you can give freedom and responsibility, how you can remove processes and value people over processes, and how you can build a mindset where you can continuously develop, evolve without diluting the efficacy of the applications that you are deploying. I would like to end by sharing what DevOps means for me as an engineer. I work on something called as Netflix Drive. Netflix Drive is a very poorly named clone of Google Drive. What we do is, like in Google Drive, you can share photos and images. Netflix Drive allows artists around the world to collaborate on movies together. So they can share drawings and movies and editing that they've done with each other, and then build movies sitting at their homes. This was especially useful in COVID times when you couldn't come to one particular place to work. It's an edge software, which means it runs on your machines like Windows, Mac OS, and CentOS. For CI/CD, which is continuous integration, continuous delivery, I use Jenkins, Spinnaker, and Mac VM instances on AWS. For deployments in these different environments, I use the Brew installs on Mac OS, Chocolatey packages on Windows, and Yum on CentOS. Sentry is used for logging, and we have in-house tools for metrics and observability. I hope my presentation was able to throw some light on what how Netflix has evolved and does its DevOps. I would be very happy and thankful if you folks can connect with me on LinkedIn. Here is the QR code. I thought this would be easiest to share with everyone. So if you can scan this, you'll be able to get my connect request in your phone, and we can connect. And now I would like to open the floor for any questions if you may have for me.
Thank you very much, Tejas. Thank you for your time and sharing your knowledge. And now, ladies and gentlemen, after every speaker, we will have a Q&A period. So there's going to be a different QR code that comes up on screen right now. And you can scan the QR code and submit your question. I'll just give you 2 moments to do that as we get the QR code on screen. And then we will select a few questions to ask Tejas. You can go ahead and use this QR code and submit whatever questions you have. I'll just give everybody 1 or 2 minutes. All right, Tejas, we have our first question for you. I think you can hear me. So the first question is, do you have a staging environment? A staging environment, yes, go ahead.
Yes, so we actually, the idea is we do have staging environment. We actually have 3 environments. One of them is the dev environment. The other one is a staging one, and the final one is a production one. But the beauty is every service owner, everyone who owns a microservice has their own staging environment. So we do not have a company-wide staging environment. everyone has the freedom and responsibility to choose their staging environments and design it the way they want. The idea is that if the interfaces between the services are constant, and if you've done the right APIs with versioning, your code change would be, or your health checks should be able to prevent a situation where you introduced a bug. So that's how we've designed it. That's why we have microservices where everyone can evolve. There are some services that do not even have staging environments. At that point, it becomes the developer's responsibility to ensure that they've done the due diligence before they deploy the services to production.
Thank you so much. Thank you so much for your answer. Another question that we have is, what strategies does Netflix employ to minimize downtime during deployments or updates?
Yes, that's a great question. There are many strategies we employ. First of all, when you deploy something, there are many ways in which you can deploy things. Just for the folks that are curious about the terms that are used, there are phased deployments, there are red, black, tree deployments. What that means is, let's say you have 10 machines that are running a previous version of code. Every service has something called as a health check. What that means is when the service comes up, is it healthy or not? And being healthy is determined by a series of custom checks. Let's say the service can write to its disk or not, the service can connect to the network or not, are some of the most active APIs or critical APIs working fine or not? Only when all of those tests are done within a service is a service marked as healthy. So when you start deploying a new version of your code, only 1 or 2 instances of the new code come up. And once they are healthy, that's when you actually bring down the older code's 2 instances. This is called phased deployment. At Netflix, we actually, for some services, we deploy only in one availability zone. An availability zone can be thought of as a particular region in the world. So we will only make some changes in one region of the world. Once we get confidence that this is working fine, that's when we slowly roll it out to other regions of the world. You would be it's very common to see when Netflix comes up with, hey, we'll start with multi-household usage, or we'll start with the ads plan. It's only in US or UK initially, or in US and Canada, and then it slowly trickles down to rest of the world. That is our way of actually getting feedback and testing. And that's how we avoid having situations where like Netflix goes down. The other thing we do is we introduce feature flags. What this means is, hey, this is a new piece of code I want to add, but let me control adding this feature with a flag. The flag can be set externally. So I deploy my service, but I can write the flag separately whenever I want. So I will first deploy the service to everywhere. And then for just a particular availability zone, for just a subset of the users, let me externally inject this flag. And then we observe and monitor. And if we see that the alerts are rising, we just flip the flag back. So this means that the service goes to its original state and that feature is not enabled. That's a common technique used in many companies, and Netflix also does that. So these are some of the ways in which we prevent ourselves from going down.
Thank you very much, Tejas. Another question that we have, with so many interconnected microservices, how does Netflix trace errors and faults across them?
That's a very good question. It's very difficult. When you have microservices that are talking to each other, a particular request may have traversed 50 microservices before actually, finishing. So we use a bunch of things. One of them is service mesh techniques. There are many tools for service mesh now. You can look up that term if you're not aware of it. And what it does is, for every request, it actually attaches a request ID and a trace ID, and you can trace how these requests flow through the system. If you have systems that are more client server based, where you have REST responses, it's easier to track that through service mesh. Envoy is a good example of a service mesh framework that allows you to do that. However, there are complications here because many systems are not client server based, where a client sends a request, a server returns a response. Many systems are polling based, where client puts a request in a queue, a server picks up the request from the queue, and the client just puts the request and comes back. And the server can perform the request in the background, and then when it has a response, it returns the response back to the client. Those are more difficult ones to actually trace across. So we have built some proprietary ways of doing that. However, that's an ongoing complicated field of research as well, where observability for such systems and at this scale of microservices is only observed at Netflix. So we are working actively on those parts.
Thank you very much for such thorough answers, Tejas. One last question, maybe easy, maybe not so easy. Do you back up your data, and how could you expand on that?
Yes, we do back up our data. So if you think about Netflix data, we have exabyte scale data. Because we use only AWS, we also leverage most of the tools that AWS gives for backups. So we if you think about where data is stored in AWS, there are many storage alternatives that cloud provides. There are object stores, file systems, there are block stores as well. uh, for a lot of our applications, we actually use object stores, and the reason is objects are more scalable, and they provide a uniform way of archival. They also perform a uniform way of lifecycle management. The other advantage of object stores is it provides you natural versioning of objects. So our backups for a lot of cases are actually just some versions of the object that we've kept around. And then we stitch together these versions to go to a previous point in time. That is how our backup story has evolved. A lot of companies actually have different cloud providers on which they back up the data. However, the challenge is to back it up on a different cloud provider, you have to first take it out from the first cloud provider and then put it in the next one. Taking out data from cloud is more expensive than putting data into cloud, because cloud charges egress costs, and they are not incentivized when you want to move to a different cloud provider. So they punish you by actually making you pay money when you take data out. So we have tried to just rely on AWS's native backup replication strategy and have multiple availability zones and multiple regions where our services run. So we try to run in active mode when it comes to services, and when it comes to data, rely on versioning for backups.
Thank you for such a thorough answer, Tejas, and thank you for your time, especially sharing your expertise despite the time difference. We'll close the question and answer period off here, but please, if your question did not get addressed, feel free to connect with Tejas on LinkedIn, and all of our speakers are here, of course, to share their knowledge with you. Thank you so much, Tejas, and have a wonderful night. Thank you for being with us.
Absolutely. And thank you so much for everyone who came here. And thanks to everyone in Armenia who invited me over. It's an honor and a pleasure. And I am very excited to come there next year in whatever capacity. So I look forward to the Jump conference in the next iteration. Thank you so much.